In this video, we're going to do a quick review of naming compounds. We're going to start off with naming ionic compounds. Ionic compounds are those made up of a metal and a nonmetal. And the major rule for naming such compounds is first you name the metal and then you name the nonmetal. What you need to remember is for the nonmetal, you need to change its ending to IDE. So over here we have an example, NaCl. First of all, I know this is ionic because there's a metal over here and a non-metal over here. The metal is sodium. If you forgot what Na is, you just go in your periodic table. Here's Na, sodium. You don't change its ending. The non-metal, Cl, is chlorine, which is over here, chlorine. You have changed the non-metal's ending to IDE. Sodium, chlorine becomes chloride. So this was chlorine at first. Cross out the INE, it becomes chloride. Here are some common endings for nonmetals that you'll sometimes see. Most of them are fairly straightforward. Bromine becomes bromide, chlorine, chloride, iodine, iodide. Some of them are a bit less intuitive. So for example, sulfur becomes sulfide, phosphorus becomes phosphide, oxygen becomes oxide, nitrogen becomes nitride, hydrogen becomes hydride, and then it's not listed here, but fluorine becomes fluoride. So the general rule, again, just name the metal, name the nonmetal, change its ending to IDE. So let's go ahead and try these here. I recommend you pause the video, try it yourself, and then check your work by unpausing the video and seeing my solution. So here we have BeF. Be is our metal, F is our nonmetal. We don't change the name of the metal, so that's beryllium. So if you don't remember beryllium, beryllium's over here. Beryllium. The nonmetal is fluorine, but the ending changes to fluoride. So beryllium, fluoride. Here we once again have an ionic compound. We have a metal and a nonmetal. The little number won't change our rules here. We're just naming the metal and then naming the nonmetal and changing the ending of the nonmetal. So the metal is lithium. If you forgot that, you can go here. Li is lithium. The nonmetal, sulfur, becomes sulfide. Here we have another ionic compound. We have calcium, we have bromine. So the metal is calcium, doesn't change the ending. Bromine becomes bromide. Calcium bromide. Now, we're going to do naming of ionic compounds, once again, metal and nonmetal, but sometimes you'll have a metal that can have more than one charge. So if you go to your periodic table, you'll see there are some metals that have more than one charge, like manganese, iron, cobalt, nickel. And a bunch of metals only have one charge. That's not a big deal, but here we have some that have many charges. When you have metals that have many charges, you have to indicate which charge you're dealing with. If you have one charge, it doesn't matter, right? Because there's only one sodium. So there's no point in me saying sodium 1. There's only one magnesium. There's no point in me saying magnesium 2, okay? However, I have, for example, 2 coppers. So if I have 2 coppers, I have to say which copper I'm talking about. Is it copper 2 or is it copper 1? It's like if I have 2 students with the same name in the class, Alex and Alex. If I just say Alex, they won't know who I'm talking about. So I need to say Alex and maybe the first letter of their last name, or maybe Alex 1 and Alex 2, just so they know who I'm talking about. But if only one person has that name, I don't really have to say the last name or have another system because there's no confusion there. So if you have a metal with more than one charge, you have to indicate which charge you're dealing with by using a Roman numeral. The Roman numerals are listed here, number 1, 2, 3, 4, and 5. So for example, here we have NiCl2. Once again, we know this is ionic because we have a metal and we have a nonmetal. The rules are the same. You name the metal first as nickel, and then the nonmetal as chloride because you change the heading to IDE. But you need to recognize that NiCl2, the nickel there, can have either a charge of 2 plus or 3 plus. So you have to indicate what the charge is. To do that, you do what's called a reverse crisscross. You have nickel over here with the imaginary one that you don't see, Cl2. You just bring the charges back up here, and you get Ni plus 2, Cl minus 1. So that means this was a nickel 2 ion, so nickel 2 chloride. Again, I didn't have to do that up here because all these metals only had one charge each, so there's no point in indicating it. But when the metal has more than one charge, then you have to indicate which one you have. So you can try the examples down below. I recommend you pause the video, then unpause to see if you're on the right track. Okay, so here we have FeBr3. First, recognize this ionic by noticing you have a metal and a non-metal. Next, recognize you have a metal that can have more than one charge. That's your iron, 3 plus and 2 plus. So what I do is I write down iron first, and I'm going to put brackets because I know I need to put a number in there, Roman numeral, and then bromide. So at least you have part of the work done. Your next step is to figure out which iron you have by doing the reverse crisscross. So Fe1Br3, bring the 3 back up here, the 1 back over here. We have Fe plus 3. The reason I put a plus because metals are positive, they lose electrons, and Br minus 1. Non-metals are negative, they gain electrons. So we have the iron 3 bromide. All right, let's try the next example, CO2S3. So once again, it's ionic because we have a metal and a non-metal. We know the CO is cobalt, and the sulfur changes to sulfide. And if you look in your periodic table, you'll see cobalt can have more than one charge. Cobalt can be 2 plus or 3 plus. There are other possible charges for a lot of these, but they're not always listed. The ones that are listed are the most common charges. So 2 plus or 3 plus, we have to figure out which one we're dealing with. So we have CO2, S3. Bring the 2 back up there, the 3 back over here. We have CO plus 3, S minus 2. So that means we have the cobalt 3 sulfide. Okay, and the last one we're going to try out here is CuO. So once again, we know that we have an ionic compound. We have copper as our metal. We know that copper can have more than one charge, so we'll put brackets there, and then oxide, because oxygen becomes oxide. So we have to figure out which copper we're dealing with. And this one's a bit tricky, so I'm going to show you to be very careful here. You have Cu1O1. You do the reverse crisscross, and you get Cu plus 1, O minus 1. Now, before you celebrate and think this is plus 1, copper 1, you have to be careful. Notice your oxygen has a charge of -1 here. That's not the actual charge of oxygen. Remember, oxygen has to be 2 minus. For all the other ones that we did, the charges were correct of the non-metal, -1, -2. So we could trust that this number here was okay. But here, the charge of oxygen is not right. It should be -2. So I can't really trust that plus 1. Remember, when you're doing ionic compounds, you have to reduce. So chances are this was actually reduced. So we need to unreduce. What do? We want to get back to -2 for oxygen, since that's what it was in the periodic table. So to get back to 2, we have to multiply by 2. Multiply everything by 2. This one and this one. And so it's Cu plus 2, O minus 2. And so that means this was actually copper 2 oxide. So just be careful with something like that, because sometimes they could have been reduced. To make sure that they were not reduced, what you do is you check the non-metal. The non-metal can only have one possible charge. If it matches what's in the periodic table, you know it was not reduced, you're all good. But if it does not match, you have to unreduce. So basically multiply by a number to get back to the charge in the periodic table, and then you'll get the charge of the metal that you are looking for. Lastly, we're going to do some naming for more ionic compounds, but this time we're doing it for ionic compounds that contain polyatomic ions. polyatomic ions are these ions over here. You'll be provided with them on the tests, quizzes, and assessments. And so when you're naming these, all you have to do is name the metal and then the polyatomic ion. That's it. You don't change the metal name. You don't change the polyatomic ion name. You just name the metal and the polyatomic ion, and you can find the polyatomic ion in your periodic table that's provided to you. It won't be in the periodic table itself, but it'll be with your data tables. It'll be a table kind of like this over here, and you'll be able to see what they're called. So here we have potassium and NO3. NO3 is over, well, it's not in this table here, but you would be given this in a table generally. NO3 is actually, so NO3 minus is nitrate. Like that. So potassium nitrate. Now, let's try this one. You can pause the video and try it yourself. Here I know I have an ionic compound that contains a polyatomic ion. Ionic because it's metallic, a metal element there, and then there's a polyatomic ion over here, an ion with more than one charge. So I have magnesium, and then I have CO3. I can go look for that right here. The charge is not written down because there was crisscross happening there, but this is magnesium carbonate. Let's try the next one. Here we have Li2CrO4. So we know it's ionic with polyatomics. So this is lithium. The CrO4 is over here. That's chromate. We can try NH4Cl. So it looks tricky because a polyatomic ion comes first, and that's okay. It can happen sometimes. NH4 is actually just ammonium. So we have ammonium. And our nonmetal is chlorine, which becomes chloride. So here we had to change the ending of the second element just because it was a nonmetal, but we didn't change the polyatomic ion itself. I'm going to put one more here for you to try out yourself. So let's do Fe, and then we'll do CO3. So try this out, see if you're on the right track by unpausing after you're done trying it out. So here we have a metal and a polyatomic ion. What's interesting is you know that this metal is a multivalent one, meaning it can have more than one charge. And then we have carbonate here. You don't have to change that ending. So the tricky part is trying to figure out what iron you're dealing with. Is it 2+ or is it 3+? So you have to do your reverse crisscross. So be careful. When you do reverse crisscross with polyatomic ions, if there's no bracket around them, put them in a bracket like this. And outside there's an imaginary 1. If there is a bracket, then you just use the number from the outside that's already there. Here there's a 1 as well. You do your reverse crisscross like this, and you get Fe1 plus 1, then CO3 minus 1. Be careful. CO3 is actually 2 minus or minus 2. So that means that we can't trust this here. We have to unreduce to get, so we have to get this back to 2 minus. So in other words, we have to multiply everything by 2. When we do that, we get Fe plus 2, CO3 minus 2, like this. So now we can trust this number. We have iron 2 carbonate. So in this video, we saw how to name ionic compounds. We saw simple ionic compounds with just the metal and the nonmetal. Name the metal, name the nonmetal, change its ending to IDE. We saw ionic compounds that contain element metals which can have more than one charge, or they're called multivalent. To indicate the charge of that metal, you have to use a Roman numeral. And to find what the charge is, you basically just need to do your reverse crisscross. You name the metal, you name the nonmetal and change the ending to IDE. You do the reverse crisscross to find the Roman numeral. How do you know if you have a metal that has more than one charge? Just go to your periodic table and you'll see more than one charge listed. If it doesn't have more than one charge, you don't do Roman numerals. Then we saw how to name ionic compounds that contain polyatomic ions. And polyatomic ions, eventually you do have to memorize them. For now, though, they'll be provided to you on a table like this. All you do is you name the metal and you name the polyatomic ion. You don't even change it. You don't even change its ending. These are the easiest ones to name. Sometimes, though, you will have a metal with more than one charge. You have to do the reverse crisscross to find the charge of that metal. Just make sure your polyatomic ions are in brackets so you don't destroy the polyatomic ion by moving its subscript from the atom. You want to make sure you choose the number that's outside the bracket there. In the next video, we're going to take a look at how to name covalent compounds.